Alright, let's talk about motors today. Sorry, my voice is a little messed up and kind of sick, but I thought I would make a little video about motors because I don't think a lot of people understand the heating up of a motor. So here we have a G&G motor. It's just something you get from a Combat Machine or a GR16. And here is a G&G bevel. And these two mesh together because they're made by the same brand. So you can see that this would slide over this pretty easily. Okay. Now, to explain, right here there's nothing. It's not touching anything. So if this was actually in the gearbox like this when you're done, it would not generate a lot of heat, but your gun would also not work. It might, if it's really close, it might mess up your pinion. See, it's pretty close there. Now if this is up a little bit higher and it bumps into it like this at the side, that actually would really mess up your pinion and you get a really nasty screeching sound. And your motor would heat up. So the problem with the motor is usually mechanical. There is sometimes electrical resistance. Now the resistance overall, that's the buildup that the motor cannot turn properly, efficiently, and cycle your gearbox. So, for instance, if the pinion doesn't match with the brand and it's a little bit smaller, it works actually a little bit harder because it has to make itself mesh together. And if you do not have good adjustment, like right here, this is not good adjustment at all. But let's say it's into it. If you don't have good adjustment and it's like this, it's working harder, so it's actually going to heat up faster. So if you actually disconnect this away from your bevel and you run it, you'll notice your motor runs really fast and pretty much under no load. It doesn't get nearly hot. But as soon as you slide this in and you don't have perfect adjustment, not perfect motor height, not perfect bevel to pinion mesh, your motor is working harder to turn, and as that happens, it heats up. Now generally, I should say, actually more than generally, this is for a fact, the more you shoot, your motor will get hotter, but it depends how much it works. If you have really good meshing and you have it on there perfectly, say it's about right here. Okay, I'm holding this up because that's where it should be about. There's a tiny gap between the bevel and the pinion. It's pretty tiny. But if you have it about that spot, the motor will work more efficiently. So your gears could be, there could be another issue where there's not enough good shimming. You didn't shim very well. If you didn't shim very well, it's very tight, guess what? The motor's going to have a hard time turning. It's going to be another mechanical problem. So same can be said with a piston. You got your piston to your sector gear, and let's say your piston doesn't move very easily in the in the shell, if it's not moving as fast as possible without any issues, it will become a mechanical issue back to your motor. Okay? Same can be said, this may have pre-engagement, but because you did that. But basically, that's a mechanical issue right there too. That this is not turning its easiest. It's not generating the most easiest turn it can, because again, sorry for this morning. If it can't do it very easily, it's working harder. Now, if you install a really strong spring, your motor is going to work harder. If you install, or let's say you make your motor work faster, it's going to be hotter. Basically, it's the motor's work that makes it heat up. Now, between motors, some are more efficient. So this is not as efficient as a high torque motor. So with a high torque motor, it would actually generate less heat under the conditions that you actually have perfect shim jobs, and you create a very low workload for it. So you can actually hold down the trigger and it would just not get hot very much at all. That's basically how it comes down to. So if you've got a high-speed motor and it barely pulls the M120, you put an M150 spring in it, and even if you give it more volts, the motor is working hard. It is working hard to spin, so it's going to get hotter. Now, this is the problem with an SHS motors, is they really generate a lot of heat because of this reason. They just don't have the type of power to be efficient. But if you throw in a Lonix high torque, you'll see that it's a lot more efficient. So let's talk about the electrical resistance. The electrical resistance is that it just gives enough for the motor to turn and stop. So if you have like a short or something, your motor would heat up, because as it tries to push the gear, it's actually working hard and it's stopping. The same thing can be is if you were just to do semi only. Let's say you do 500 semi shots like this as fast as you can. Your motor would generate a lot more heat because of the stop and go than it would if you were just to hold down full auto for 500 BBs coming out of your gun. So if you don't have a very good electrical current coming in with all the electrons from your battery to the MOSFET to the motor, it's going to have no efficiency and it's going to start to heat up, because you just are not making it run under how it's supposed to run. Okay. Again, I apologize for being sick. There's not much I can do about that. But what I'm explaining is very good information. Now, same can be said if you run a smaller battery that barely cycles this gear set with spring, because it just cannot run efficiently. It's not pulling the gears very well. So basically everything is stated. There's more advanced things that make this heat up. For instance, the shimming inside you've got between the magnets. But I think I'll take apart a motor in another video and kind of go over the parts and what they do. You'll notice that after a long time after shooting that the dirt builds up in here with the communicator, and that makes an electrical resistance problem. So you got to take out your brushes right here and here and clean them, as well as the communicator, which is that gold circular shaft area right there that the negative and positive side connect to make your motor run. Now, your motor's power is generated by the there is little wires in here that go around it. I think it's called the armature. It's the number of turns that will create your torque, but at the same time it's how well your magnets are powerful. If you were to turn your pinion and notice that it turns very lightly, it means your motor doesn't have a lot of power. You can see here this does not have a lot of power at all. So that's a good way to tell if your motor's got some power to it. Also, it would be very magnetized, so if you were to put it close to something, it would pick it right up. In this case, this motor barely has any. If I put another motor to it, it does barely even stick to it. So this just does not have a lot of power. It's the reason why a lot of heat is built up. Also, because, like I said before, if there's a resistance build up in here, electrical resistance, that can be these brushes. Sometimes they are built straight or do not touch the communicator very well. Because of that, it's like applying electricity, or electrons, excuse me, very slowly to the motor, because it's such a small amount, so your motor would not run efficiently. Now, some of these motors actually have that, and people will take out the brushes and shave them down so they fit to the motor communicator a little bit better. Alright, so that's pretty much explained basically to the motor heat. I think I will go from here, and I'll catch you guys later.